Welcome to tonight's exploration of one of Earth's most extreme climate events, the time it rained for 2 million years. If you enjoy learning about Earth's dramatic past, please tap subscribe, comment, and hit like so others can discover these fascinating events too. Now let's journey back to the Carnian pluvial episode. 234 million years ago, during the Triassic period, something happened that would reshape life on Earth forever. The climate shifted, the skies opened, and then it rained. Not for days, not for months, not even for centuries. It rained for somewhere between 1 and 2 million years. Continuous, relentless rainfall that transformed the entire planet from a largely arid world into a waterlogged greenhouse. This wasn't just heavy weather. This was a fundamental reorganization of Earth's climate system, an event so profound that geologists can still read its signature in rocks laid down across every continent. They call it the Carnian pluvial episode, though some scientists simply call it the wet intermezzo, a strange interval of moisture interrupting the otherwise dry Triassic world. When we talk about what the world was like before this event, we need to understand that the Triassic was hot, brutally hot. The supercontinent Pangaea dominated the globe, a massive landmass stretching from pole to pole, and its interior was essentially a vast desert. There were no ice caps, sea levels were low, the climate was monsoonal in some regions but predominantly arid. Life had recovered from the Great Dying, the Permian extinction that had wiped out 90% of species, but it was still finding its footing in this harsh, dry world. Then came the rain. The trigger, scientists believe, was volcanism, massive volcanism. In what is now Western Canada, a large igneous province called the Wrangellia Terrane began erupting. These weren't ordinary volcanoes. This was flood basalt volcanism, the kind that pours molten rock across thousands of square kilometres, releasing enormous quantities of carbon dioxide and other gases into the atmosphere. The Wrangellia eruptions pumped greenhouse gases into the air at rates that would make modern climate change look gradual. The carbon dioxide trapped heat, temperatures soared, the warming ocean began to release more moisture into the atmosphere. Weather patterns shifted dramatically, and then the rain began, falling across Pangaea in quantities that seem almost impossible to imagine. Evidence for this event comes from multiple sources. Geologists examining rock formations from this period find a sudden shift in sediment types. Desert sandstones give way to mudstones and claystones, rocks that form in wet conditions. There are coal deposits from this time, indicating lush vegetation, appearing in regions that were previously too dry to support forests. Fossil soils show signs of intense weathering, the kind that only happens under heavy sustained rainfall. In the Germanic basin of Central Europe, there are hundreds of meters of sediment laid down during this wet period. In North America, in China, in South America, the geological record tells the same story. Dry conditions, then sudden wet conditions lasting for an extraordinarily long time, then a return to drier climates. The consistency of this pattern across the globe confirms this wasn't a local phenomenon. This was planetary. The rain transformed ecosystems completely. Before the Carnian pluvial episode, conifers dominated the landscape where there was vegetation at all. These were tough, drought-resistant trees adapted to the arid Triassic world, but the sustained rainfall created conditions where different plants could thrive. Ferns expanded dramatically. New types of conifers evolved. The first ancestors of modern tree groups began to appear, taking advantage of the newly wet conditions. Lakes formed where there had been desert. Rivers that had been seasonal trickles became permanent, powerful waterways carving through the landscape. Wetlands expanded across vast areas. The whole character of Pangaea's interior changed from a place where water was scarce and precious to a place where water was everywhere. Constant, unavoidable. Marine environments changed too. The increased rainfall meant more runoff from the land, carrying nutrients into coastal waters. This led to algal blooms, periods of oxygen depletion in the oceans, and significant stress on marine ecosystems. There are layers of black shale from this period, rocks formed in oxygen-poor conditions, testament to the struggling seas. The extinction rates during the Carnian pluvial episode were significant, though not as catastrophic as the great mass extinctions. Many species couldn't adapt to the sudden shift from dry to wet conditions. Marine reptiles, primitive relatives of crocodiles, various invertebrate groups all suffered losses. But extinction creates opportunity, and the Carnian pluvial episode opened up ecological niches that would be filled by groups that would come to dominate the Mesozoic. Dinosaurs emerged during or shortly after this event. Before the rains, dinosaurs were marginal creatures, minor players in ecosystems dominated by other reptile groups. After the rains, they began their rise to dominance. Some scientists argue that the Carnian pluvial episode was the key event that allowed dinosaurs to diversify and spread, that the environmental shake-up created conditions perfect for their evolutionary success. The first true mammals appeared around this time too. Small, probably nocturnal creatures, but they were there, taking advantage of the changing world. Pterosaurs, the flying reptiles, may have originated during this period. The modern groups of conifers, the ones that would dominate Jurassic and Cretaceous forests, diversified in the aftermath of these rains. Think about what 2 million years of rain means. That's not a catastrophic flood. It's not even a particularly long storm by human standards repeated over and over. It's a fundamental shift in climate state. where rainfall became the norm rather than the exception, where wet conditions persisted generation after generation, for a period of time longer than our species has existed. The temperature during this period was extreme. Some estimates put global average temperatures at over 30 degrees Celsius, significantly higher than today. The increased greenhouse gases not only warmed the planet but also intensified the hydrological cycle. Warmer air holds more moisture. Warmer oceans evaporate more water. All that moisture had to come down somewhere, and it came down everywhere, reshaping the world. Rivers during this time would have been enormous compared to their dry period equivalents. Deltas expanded. Sediment transport increased dramatically. The erosion rates across Pangaea would have been immense, as all that rainfall worked to break down rock and carry it away. Mountains that had stood through the dry, early Triassic found themselves under assault from relentless precipitation. The animal life that survived had to adapt quickly. Creatures that had evolved for arid conditions either needed to develop new strategies or perish. We see evidence of this in the fossil record, where species adapted to dry environments disappear, replaced by species better suited to wet habitats. Amphibians, which had struggled in the dry early Triassic, expanded during the wet period, taking advantage of the abundant water. Plant life underwent a revolution. The coal deposits from this period tell us that vast swamp forests formed, similar to those of the Carboniferous period, hundreds of millions of years earlier. These weren't quite the same forests, the species were different, but the conditions were similar, enough that coal formation began again in earnest after a long dry spell. The end of the Carnian pluvial episode is almost as mysterious as its beginning. The rain didn't stop suddenly. Instead, over perhaps hundreds of thousands of years, conditions gradually returned to the drier state that would characterize the rest of the Triassic. The Wrangellia volcanism ended, carbon dioxide levels stabilized, the climate system found a new equilibrium, one closer to the pre-rain conditions but not identical. What remained was a transformed world. The species that had emerged during the wet period didn't disappear when things dried out. Dinosaurs continued their expansion. The new plant groups persisted. The ecological reshuffling that occurred during those 2 million years of rain had permanent effects that would ripple through the rest of the Mesozoic era. Scientists study the Carnian pluvial episode not just as a curiosity of deep time, but as a window into how Earth's climate system can undergo rapid, dramatic changes. The parallels to modern climate change are obvious, though the scales are different. We're adding greenhouse gases to the atmosphere much faster than the Wrangellia volcanoes did, but the basic mechanism, warming leading to changes in precipitation patterns, remains the same. The geological record preserves this story in remarkable detail. Core samples from ancient lake beds show annual layers, like tree rings, each one representing a year of that 2 million year rain. Chemical analyses of these rocks reveal changing conditions, variations in rainfall intensity, periods where things were slightly drier or wetter within the overall wet trend. Fossil evidence shows us the creatures that lived through this time. Fish adapted to freshwater conditions become more common in the fossil record. Aquatic reptiles diversified. Even insects show adaptations to wetter conditions, with species emerging that were specialized for life in and around water. The Carnian pluvial episode stands as one of Earth's great climate events, a reminder that our planet's climate is not stable, not unchanging, but a dynamic system capable of dramatic shifts. 2 million years of rain reshaped continents, transformed ecosystems, and set the stage for the age of dinosaurs. The world that emerged from those rains was fundamentally different from the world that entered them, and life on Earth followed new paths because of it. The atmospheric composition during this period was radically different from today. Carbon dioxide levels may have been 4 to 6 times higher than pre-industrial levels, creating a greenhouse effect that fundamentally altered global weather patterns. This wasn't just about temperature. The entire atmospheric circulation changed. Storm systems that we would recognize became larger, more intense, more persistent. The jet streams shifted. Ocean currents reorganized themselves in response to changing temperature gradients. Coastal regions experienced dramatic transformations. Sea levels fluctuated as the climate shifted, and the increased rainfall meant river deltas expanded rapidly, building out into shallow seas. These delta systems became hotspots of biological activity, mixing freshwater and marine environments, creating brackish zones where new species could evolve in response to unique conditions. The impact on soil chemistry was profound. In arid conditions, minerals accumulate in soils because there isn't enough water to wash them away. But 2 million years of rain meant intense leaching. Nutrients were stripped from soils and carried into rivers and oceans. This created a paradox where, despite all the water, some terrestrial environments became nutrient poor, while coastal marine environments became nutrient rich, leading to explosive growth of marine algae and plankton. Cave systems that exist today in rocks from this period show unusual features. Speleothems, the formations like stalactites and stalagmites, grew at accelerated rates due to the constant water flow. Some caves preserve evidence of underground river systems that were active during the Carnian pluvial episode, but are now dry, their channels silent witnesses to a wetter world. The rain has long since stopped. The rocks remain, holding the memory of that wet world in their layers and chemistry. Scientists continue to study them. learning more about what triggered the rain, how ecosystems responded, and what finally brought the wet period to an end. Each discovery adds another piece to the puzzle of Earth's climatic past, helping us understand not just what happened then, but what might happen in our changing world now. The Carnian Pluvial episode reminds us that Earth has seen extremes we can barely imagine, that climate can shift in ways both gradual and profound, and that life, while resilient, must adapt or perish when the world changes. For 2 million years it rained, and nothing was ever quite the same again.